Today, we're going to continue with our learning target of I can perform operations on expressions. This week, we're going to focus on subtraction. Remember that we started 2 weeks ago with addition of polynomial expressions or algebraic expressions, and we learned how to combine like terms. We also spent last week talking about multiplying expressions together and something called the distributive property. This week, we're going to focus on performing operations on expressions, but this time it's going to be subtraction. And subtraction is going to involve what we learned when we did addition and when we did multiplication. We're going to have to use both the distributive property as well as the skill of combining like terms. So what we're doing here is we're subtracting algebraic expressions from one another, and we are simplifying those expressions. All right, I broke it down into a few basic steps. Step number 1, we're going to distribute any negatives through parentheses. Step number 2, we're going to combine our like terms together. And step number 3, we're going to make sure we write our final expression in something called descending degree order. We'll talk about that in just a minute. Let's take a look at the first example. We're going to simplify the expression 4n to the fourth minus 2n to the third minus the entire expression 2n to the fourth plus 4n to the third. Notice the minus sign in between those two expressions, and notice that the entire second expression is in parentheses. That means we're going to consider that whole expression as a group. And because it's in parentheses, that means we're going to subtract every term inside that expression, or every term of that expression. In other words, what we're going to do is we're going to distribute this -1 through the parentheses. We are going to subtract every term by distributing a -1 to every term. Remember, distribution means multiplication. So let's go ahead and let's simplify. Notice that the first expression, even though it's in parentheses, nothing is happening to it. It's just waiting for the -1 to be distributed to the second set before it can be combined with those terms. So the first expression is not going to change. 4n to the fourth plus 2n to the third. Now, as we distribute the negative through the parentheses, remember, every term in the parentheses is going to be multiplied by -1. So when you multiply something by -1, remember, what it does is it changes the sign. So if it starts out as positive, when you multiply it by -1, it's going to become negative. And if it starts as negative, if you multiply it by -1, it's going to become positive. Why? Well, let's just recall for a second our rules for multiplying integers, okay? Rules for multiplying positives and negative numbers. If we have a positive times a positive, that's going to be equal to a positive. If we have a positive times a negative, or if we have a negative times a positive, those are going to be equal to a negative. And if we have a negative times a negative, that's going to be equal to a positive. So as we think about those rules moving forward, let's remember that when we multiply something by a -1, what it's going to do is it's going to change the sign. So let's go back to our example. Remember, we just wrote the first expression down because nothing was happening to it. The second expression now is going to get multiplied by -1. So -1 times 2n to the fourth is a -2n to the fourth. And when we write down a negative, we want to express that as a subtraction. So we're going to put minus 2n to the fourth. And then we're going to distribute the -1 to positive 4n to the third. So -1 times positive 4n to the third is going to be negative 4n to the third. And that negative is our minus, so minus 4n to the third. Now, this is the point where we are going to need to combine our like terms. But we're going to do two things at once. We're going to do steps 2 and 3 at the same time. So before we combine our like terms, we need to talk about something called descending degree order. When we write an expression, the best way to write that expression is in something called descending degree order. So you're probably asking, well, what does he mean by that? Well, the degree, let's talk about that word degree. When we talk about the degree of a term, what we're talking about is the highest exponent, okay? The highest exponent in that term. So for example, if we want to look at the term 4n to the third, right, that first term in there, the degree of that term is 4 because the exponent is 4. Moving along, plus 2n to the third, the degree of that term is 3 because the exponent is 3. Moving down, minus 2n to the fourth, that's a degree 4, and minus 4n to the third, that's a degree 3. So when we write in descending degree order, what we're going to do is we're going to start with the terms that have the highest exponents, that are like terms. That would be our 4n to the fourth minus 2n to the fourth. 4n to the fourth minus 2n to the fourth is 2n to the fourth. And then we move down to our degree 3s. Positive 2n to the third minus 4n to the third is negative 2n to the third. So we're going to write minus 2n to the third. And what we've done is we've combined our like terms and we've made sure that our terms are written in descending degree order. So descending degree, descending means to go down, right? When you descend a staircase, you go down the staircase. Descending degree means highest exponent down to the lowest exponent. This is the most appropriate way to write an algebraic expression, aka polynomial. Let's do one more. Notice in this example, I actually have 2 minuses in front of an expression. So what I need to do is distribute twice. I need to distribute this -1 through the parentheses, but I also need to distribute this -1 through the parentheses. So the first grouping does not change, right? There's nothing being distributed out here, so I don't need to multiply it by anything. It's going to stay 4r to the third plus 4r to the fourth. Now's where we get to distribute. -1 times r to the third is minus, or negative, r to the third. And -1 times positive r to the second is negative r to the second, or minus r to the second. Lastly, we're going to distribute our purple -1 here through the parentheses. -1 times 6 is -6. And -1 times negative r to the fourth, don't forget about that guy, right? Negative times a negative is a positive. So we have plus r to the fourth. Let's take a look and see if we can identify our like terms. All right, so we've got 4r to the third and minus 1r to the third. Those are like terms. And we have positive 4r to the fourth and positive 1r to the fourth. Those are like terms. We have this term minus r squared, but you know what? There's nothing to combine it with. There's no other r squareds. And we also have this minus 6 by itself, and there are no other like terms to combine that with. So remember, what we want to do is write this in descending degree order. And the degree is the exponent. So we want to start with the highest exponent terms and then work our way down to the lowest. So the highest exponents that we see are the terms that have r to the fourth power. Let's go ahead and combine those together. So let's say we have positive 4r to the fourth plus 1r to the fourth, and positive 4 plus 1 is positive 5r to the fourth. And now let's work our way down to the r to the thirds. we have 4r to the third minus 1r to the third. And again, we're working left to right, right? 4r to the third minus 1r to the third is positive 3r to the third. So we're going to write plus for our positive 3r to the third. And we're going to move down to the r to the seconds. Now, there's only one term that has an r to the second. That would be minus r to the second. There are no r to the firsts, and there's really only one other term left that doesn't have any r's at all. So that's going to be our last term, which is minus 6. So what we have are our terms in descending degree order. 5r to the fourth plus 3r to the third minus 1r squared minus 6. So this is how you subtract expressions. You distribute the negative 1 through the parentheses by multiplying every term in there by negative 1, and then you combine your like terms and write your final expression in descending degree order. Keep in mind, you still have those rules for multiplying positive and negative numbers that you have to think about as you distribute your negative 1. I hope this was clear. You'll get some practice in. Good luck, and if you have any questions, please let me know.